Hello everyone, welcome back. In this video, we're going to look at some examples of solving inequalities. And when we're solving inequalities, there's one thing we want to remember. It's basically the same as solving any ordinary equation, but with one extra rule. And that is, if we multiply or divide both sides of an inequality by a negative number, then we have to flip the direction of the inequality sign involved. So keeping that in mind, let's go ahead and start solving this inequality. When is 3x minus 2 greater than 4? And so just like solving an equation, when we're trying to solve an inequality, we're trying to get the variable by itself on one side. And so we're trying to get x by itself on one side of this inequality. And so we can use the same steps we use when solving an equation, but we just got to be aware of multiplying or dividing by a negative. And so the first thing we want to do to get x closer to being by itself is adding 2 to each side of this inequality. So if we add 2 to each side of our inequality, then we get 3x is greater than 6. And now to finish getting x by itself, we divide both sides by 3. And let's see, that gives us x is greater than 6 over 3, but that simplifies to 2. And so the solution to our original inequality occurs whenever x is greater than 2. And so we can express our answer using another inequality like we've done here, x is greater than 2, or we could use a number line to express our answer, in which case the solution would look something like this. Right? We can't include the x value of 2, so we use an open circle for that left endpoint, but then all the x values that are bigger than 2 or to the right of 2 will satisfy our inequality. And if we wanted to use interval notation, well, that would look something like the open interval from 2 to positive infinity, again, not including either endpoint. So up next, we're going to look at this inequality. When is 8 minus 1/2 of x greater than 20? And so in order to solve this inequality, our goal is to try to get x all by itself on one side of our inequality. And so the first thing we can do is subtract 8 from each side of our inequality. So that cancels out the 8 on the left-hand side. Our new left-hand side is just going to be negative 1/2 times x. And then the new right-hand side of our inequality is going to be the difference between 20 and 8, which is 12. And so now we just got to get x by itself, looking at negative 1/2 x is greater than 12. So in order to cancel out that factor of negative 1/2 in front of x, we're going to have to multiply the left-hand side by negative 2. And whenever we multiply one side of our inequality by a number, we have to multiply the other side of our inequality by that number, right? Just like how we're solving an equation. But we have to be careful here because we're multiplying both sides by a negative number. And that means we're going to have to flip the direction of our inequality sign when we write the next version of our inequality. And so we started with a greater than inequality sign. But now that we have multiplied both sides by negative 2, it's going to be flipped to a less than inequality sign. And so now let's go ahead and look at the new left and right hand sides of our inequality. If we multiply negative 1/2 x by negative 2, the negatives cancel and the factors of 2 cancel, and we're left with just positive x. And then on the right hand side, 12 times negative 2 is negative 24. And so the solution to our original inequality, 8 minus 1/2 of x greater than 20, is going to occur whenever x is less than negative 24. We can visualize that on the number line. So 0 is there, negative 24 is to the left of 0 over here. We can't include our right endpoint of negative 24, but we can include every point to the left of it. And so that is what the visualization of our interval of x values is going to look like on the number line. And then to really finish it off, we can use interval notation. And so the right endpoint of our interval is going to be negative 24. We can't include that. And our left endpoint, technically we don't really have one. We can go as far to the left as we want without bound. And so we're going to say that the left endpoint is negative infinity. And remember, we never include an infinite endpoint, so we always use those parentheses around the negative or positive infinity endpoints. All right, everyone, so in our next example, we're trying to solve a compound inequality or a three-sided inequality. And so this is read as negative 5 is less than x plus 3, which is less than 5. And so we have another little rule or thing to remember when we're working with these compound inequalities. If we want to solve a compound inequality, then we're going to solve it when we get x by itself. But instead of getting x by itself on like the left side or the right side like we did with our normal or other inequalities, now we're trying to get x by itself in the middle of the inequality, and it should be the only x involved in the inequality. So we're going to solve a compound inequality when we do our algebra and get x and only one x in the middle of the compound inequality. So in this example, it's pretty straightforward. We have negative 5 is less than x plus 3, which is less than 5. And so the x is not by itself because of that constant term of plus 3. So we're going to subtract 3 to get rid of it. But now whatever we do to one side, we have to do to all the other sides. So we have to subtract 3 from all three sides of this compound inequality. So our new left-hand side is going to look like negative 5 minus 3, which is negative 8. The middle of our inequality is now going to be just a single x by itself. Remember, that is our goal. And the right-hand side is 5 minus 3, which simplifies to positive 2. So the solution to our compound inequality is expressed using a simpler compound inequality. It's the interval of x values between negative 8 and positive 2, not including those endpoints. We can also describe that on the number line by visualizing our x values from negative 8 to positive 2, not including either endpoint, but including all the x values in between them. Or we can use interval notation, in which case this would look like the open interval from negative 8 to positive 2, using parentheses for both endpoints because we do not include the endpoints. So the thing to remember when solving these compound inequalities, you're still using all the same algebra techniques as you were with your other inequalities or equations, but now we have to really just focus on getting that single x by itself in the middle of the compound inequality. All right, let's go ahead and look at another example of solving a compound inequality. This time we're trying to figure out when is 0 less than 2 minus x less than 6, or another way to phrase that, when is 2 minus x bigger than 0 and less than 6? And so in order to solve this compound inequality, we got to get x by itself in the middle of the inequality, and it's got to be a positive x by itself. And so we can subtract 2 from all three sides of our inequality to start getting closer to getting that x by itself in the middle. The new left-hand side will be 0 minus 2, which is negative 2. That's going to be less than, well, the positive and negative 2 cancel out here. So negative 2 is less than negative x. And that's going to be less than the difference between 6 and positive 2, which is positive 4. So after subtracting 2 from all three sides of our starting inequality, we're now looking at negative 2 is less than negative x is less than positive 4. And so now to finish this off, we really just got to get rid of that negative 1 in front of x. And we can do that by multiplying all three sides of our inequality by negative 1. That's a little bit hard to write here. So equivalently, I'm just going to divide all three sides of the inequality by negative 1. That's the same as multiplying by negative 1 anyways. And so when we do this, though, we have to be careful because whenever we multiply or divide an inequality, including compound inequalities, by a negative number, we have to flip the direction of the inequalities. So these started as less than inequalities. They're now getting switched to greater than inequalities. So in the middle of our compound inequality, our negative x gets turned to a positive x. On the right-hand side, we get negative 4. And on the left-hand side, we get positive 2. And so we currently have a correct statement here. 2 is greater than x is greater than negative 4. But our inequality is almost written like from right to left instead of left to right. We usually like to express the smaller things on the left and the larger things on the right. And so we can do that if we just kind of flip everything in our inequality. And so instead of reading this from left to right, saying 2 is greater than x, which is greater than negative 4, we can read it from left to right and rewrite the inequality. So negative 4 is less than x, which is less than positive 2. So just rearranging our inequality, we get it written in the more normal way. And now that we have written the more normal way, if we want to, we can express it using the number line. And so the solution to our compound inequality is this single interval that starts at negative 4 and goes to positive 2 and doesn't include the endpoints. Or if we wanted to express this using interval notation, it'd be the open interval from negative 4 to positive 2.